here.
You don't start at the middle though?
You can start anywhere you want,
Oh. Okay.
and you can go in whatever direction you want. I just started here and went that way, started here and went that way.
And then when you subtract the two equations, that gives you like as if you were starting at the middle? Or something?
That gives it if I started, so I did this loop and I did that loop. If I wanted to do the whole outer loop instead. If I started here, it went around like that. That is the equivalent of taking this equation minus that equation. What I'm going for is that I've got three different loops from which to pick. They're not three independent equations, so I can't, I have to use this as one of my equations.
Okay.
So if the resistance is going with the current, then it's a negative, but if it's
Yes.
going against it, it's a positive?
Yes.
Okay, because it's canceling out the,
You're, in essence, losing energy.
yeah, okay.
Current flows downhill also, so if I'm going with the current, I'm going to a lower potential. So I go from high to low, so I'm losing. Phil, you look like you have a follow-up.
I don't know. Maybe, I don't know what to ask though, like. What exactly are we doing? Again?
We're trying to figure out the current flowing across the resistor.
Okay. And so you start by figuring out overall what?
So we basically assign a current to each path, and then we use our junction rule and voltage rules in order to come up with three equations for our three unknowns. We're gonna solve for the three unknowns.
Breaking it up, basically defining the individual, current.
We're finding the individual currents.
Okay.
I know that whatever current flows out of this junction has to flow along this whole path. There's no other junction in between here and here, so this all has to be the same current. This all has to be the same current, this all has to be the same current. So I create a current between any two junctions.
Okay. Yeah,
That good for now?
yeah, good.
All right, physics done, this is a math problem. Or physics done for now, we bring physics back in the end, but now it's a math problem. How do you recommend we solve three equations, three unknowns?
Matrix.
Okay, you want to do matrix?
Sure, yeah. Been doing matrices lately, so.
Everyone done matrices before?
It's been a while. Maybe it's been a while.
Good. All right, if we're gonna do,
Just create a table with a bunch of numbers.
quadratic formula's not gonna quite work here. If we wanna do matrices, by hand. All right, let's go for it. So we got B plus C plus D equals 0. First off, I'm gonna line up everything here. So I've got negative 4B minus 2B, so I have negative 6B plus 6C plus 0D. There's an implied 1 in front of all of these. Equals, so I got 8, bring it over, negative 8. One minus sign in the wrong spot, and it all gets messed up. That also is just a joy to try to figure out. All right, so now this last one, I have no B's. I have plus 6C minus 8D equals, that's 12, so negative 12.
Well, you got a nice pivot spot in the top there already.
So we claim that I've got 1, 1, 1, negative 6, 6, 0, 0, 6, negative 8 times B, C, D equals 0, negative 8, negative 12. So we just need to find an inverse matrix. So if this is A, B equals C, then I have to multiply both sides by the inverse matrix. That gets me 1, and I'm left with B equals the inverse matrix of that times C.
You can just
to the right side and augments it, right, and then,
Do the right side and augment it.
sorry, well, I guess it would already be an augmented matrix if you included the right side of the equal sign over there, instead of BCD.
Okay, like when dealing with matrices, I either have Kramer's rule, which is really sort of independent of matrices, but related. Or 1, 1, 1, negative 6, 6, 0, 0, 6, negative 8. 0, that's a 6. Where I manipulate this to get this as 1, 1, 1, the
Yep.
rest are zeros.
Yeah. And then that's your inverse from the other side, right?
Yeah.
Yeah, that's the way I was taught to do it so far. I haven't gone beyond that.
What was your differentials, right?
No, I'm in linear algebra right now.
Oh,
This is linear algebra stuff.
All right, so,
You can just leave out the 0, 8, and negative 12 though when you're trying to find the inverse of the left side.
yeah,
Yeah.
yeah. And then whatever we get, we'll multiply times the 0, negative 8, negative 12.
Oh.
So if I multiply, I need to start simplifying this somehow.
Multiply the row 1 by 6 and add it to row 2.
Then, all right, so if I do that, then I've got 6, 6, 6, seems demonic, 0, 0. Negative 6, 6, 0, 0, 1, 0. Then 0, 6, negative 8, 0, 0, 1.
I mean, your top row is just gonna go back to 1, so.
If I add them together, okay, so if I add those together, I get 0, 12, 6, 6, 1, 0.
Oh, you did the top row. I meant like to try to eliminate the negative 6 in the second row below the 1.
Okay, so you would keep the top row the same?
Yeah, keep the top row, you restore the top row. I was just saying you scale the top row to get rid of the second.
All right, so 0, 12, 6, 6, 1, 0, and 1, 1, 1, 0, 0.
Yep.
And so now if I multiply this times 4 and this times 3, I'm gonna eliminate that.
I think you can do
Oh,
it that way.
yeah.
I would divide the second row by 12 first to get the middle to a 1, but
Okay.
that's just the way I would do it. You can do it different ways.
Yeah, it's been a while since I've done the matrices bit. So if you divide this by 12
Yeah.
and this by 6,
No, I wouldn't worry about the third yet because you're just trying to get rid of the 12 in the middle to get it to a 1, so you can eliminate the 6 in the bottom after that.
wait, sorry, we're trying to get rid of the 6 there.
Yeah, but we're dealing with, I was dealing with the 12 first to get it to a 1 because you need it in reduced echelon form, so you're trying to get the middle to a 1.
Okay, so, okay, I'm with you. So 1, 1, 1, 0, 1, 0.5, 0.5, 112, 0,
Yeah.
1, 0, 0.
And so
Zero.
far, we haven't done anything with the bottom row.
Well, let's
Yeah, good.
divide by.
Yeah, you could just do it right now if you want.
Or divide by 8, 1, negative 1/8, okay. So this becomes negative 0.75, 1, 0, oops, I lost the 1 there. 0, 0, negative 1/8.
Now you gotta get rid of the point, or the negative on the bottom there.
75, so if I multiply this times 4/3, yeah, multiply that times 4/3, then that's gonna go away if I add to that.
So you'd be multiplying the middle one briefly to get rid of the bottom one. You'd be multiplying the middle one by 4/3, and then adding it to the bottom one and then restoring the middle one, just so you can get rid of the bottom one, you know what I mean?
Right, so if I multiply that by 4/3,
Yeah, your one in the middle is your pivot.
Right.
So you're gonna be multiplying that row, scaling it so you can get rid of the bottom one. But then your middle goes back to what it was. Because you don't wanna change the middle now that you have it at a 1.
right,
So you just wanna get rid of that negative 0.7 or 7.5 on the bottom or whatever that, 0.75.
0.75.
Yeah.
So I multiply the middle one by,
4/3 and add it to the bottom one and then restore the middle.
I multiply times 3/4.
Sure, yeah, sorry, 3/4.
Okay, sorry, I was getting caught up on that.
Yeah, sorry.
So if I multiply that times 3/4 and add it to this one, so I still have 1, 1, 1, 1, 0, 0. The middle one's gonna stay the same. And then 3/4 of that plus that, so that I get 0, 0. 1 plus 3/4 of a half, or 3/8. 3/8, that's 11/8. And then 0 plus 3/8. And then 1/16. And negative 1/8.
Yeah, finding the inverses gets annoying with fractions.
So then I multiply the bottom one by 8/11,
Yeah.
and that into a 1.
Yeah.
So the gluttons for punishment. 0, 0, 1, 8/11 makes that 3/11. 8/11 makes that 1/22, and then negative 1/11.
Now you gotta get rid of the 0.5 in the second row, and, yeah, I know, it's annoying.
Hey, somebody wanted something different, someone should have spoken up. All right, so,
Yeah, nobody said, no matrices.
so if I multiply the bottom one by 0.5 or negative 0.5 and add.
Yeah,
One,
and then
one,
restore the
one.
bottom. So the bottom doesn't change.
So 0, 0, 1. Is that just, can't read my handwriting, 3/11. 1/22, and negative 1/11. Top is still gonna be 1, 0, 0 for now. And this will be 1, 0, 1, 0. So multiplying the bottom by negative 0.5 and adding. So this would be
7/11 times negative 1/2.
that's 3/11.
Oh. Okay.
Yeah, by handwriting. So
3/22.
negative 3/22, so I have 1/2 minus 3/22, so that's 11/22. So it's 8/22. And then I have 1/12 minus 1/44.
Sorry, this is a bad idea. Somebody can just plug it into the calculator at this point and get the, and we can just call it good.
All right, so, and then,
You were on the right track though. We almost got there.
yeah, whatever 1/12 minus 1/44 is. All right, let's take a look at a different technique.
Plug into calculator and solve systems of equations.
Yeah, and I don't know how to use your calculators to solve it that way.
I'm sure somebody can do it with a graph calculator.
You just plot this in three-dimensional space and see where the planes meet, or the three-dimensional lines meet. All right, so we've got, so there is the matrix technique, which apparently is just riveting.
For this problem. Sometimes it's not that bad.
Yeah.
Sometimes, like at this particular problem, just the way the numbers were set up, it's just too many fractions and too annoying.
Yeah, there are times when I do set it up, and I sometimes will ask the class, do you want your final, when I do the one for the test, do you want the numbers to be integers? And the advantage of that is if you get integers, you probably should be feeling pretty good. The disadvantage is if you don't get integers, then you know you've done something wrong, so it's.
Oh, yeah.
You're now going through the torment of, all right, where's my mistake?
Mm-hmm. So you're saying you say beforehand, like your numbers at the end should be integers?
Yeah, I generally ask the class if you want them to be integers or just some random number. With a calculator, I would have used a calculator instead of fractions.
Yeah.
Just because it's physics, not math.
Well, that was some nice practice on matrices.
Yeah, that, I remember I did this a couple of years ago. I debated whether to bring inverse matrices into it, and ultimately decided that's a pain in the butt. And partly, the childhood scars is that we didn't have calculators to do it when I was in
Right.
school. All right, so 3 equations, 3 unknowns. What's another technique for solving it other than, did you actually plug it into the calculator to get the answer?
Not yet.
Okay.
I think it,
Well, the way I know to do it is to, make the variables use an equation to, like, make 6b in terms of 6c, or c or whatever. So that, and then you can plug that back into, the like top equation.
Okay, so you solve for,
Solve for a variable in terms of another variable.
and then plug in, so substitution.
Yes.
Okay, well, let's do that one. I think potentially easier than inverse matrices. So that middle equation, if I divide by 6, I get negative b plus c equals negative 8/6, negative 4/3. So c is b minus 4/3. Plug that into,
I actually got it on a calculator too, if you want the calculator.
all right, what do you have for b, c, and d?
I have, B as 10/33. The second one as negative 34/33. And the last one is 8/11.
8/11. Okay.
I basically just set it up as a matrix, just like that in the
All right.
calculator.
So then take this, plug it into the, I guess I plug it into the first one, so I get b plus b minus 4/3 plus d equals 0, which becomes 2b plus d is equal to 4/3, or d is equal to 4/3 minus 2b. I'm not opposed to making a careless error somewhere in here. Plug it into the last one, we have, if I divide by 6 here, I get c minus 4/3 d equals negative 2. So I have b minus 4/3 minus 4/3 d equals negative 2. That's not right. No, b minus, yeah. So that's c minus 4/3, okay. So I have b equals, bring that over, that would give me 2/3. Negative 2/3 minus 4/3 d plus 4/3 d. Plug that into here. So d equals 4/3 minus 2 times negative 2/3 plus 4/3 d. Okay, so d equals 4/3 plus 4/3 minus 8/3 d. Bring that over, so I have 8/3 on the right, and I have 11/3 over there. D. So d is 8/11, which is what we have up there. Units? let's not lose track of what we're trying to find here.
Amps.
Yes. Once I have this, I can plug into here to find B. So I got negative 2/3 plus 4/3 times 8/11, which is negative 22/11 plus 32/33. Wait, no, sorry. Try that one again. Top and bottom by 11. It's got negative 22/33. So that gives me 10/33 for B. Which is different from what we have over there. So,
That's right. 10/33 B.
oh, yeah, sorry. Yep. Amps. And then A, or not A, we have B, we have B, C. Should be that minus 4/3. Would be,
10/3 minus 4/3. Okay, so it looks like C is maybe wrong.
B minus 4/3, so minus.
44/30.
Oh, wait, yeah, I was thinking thirds and 30/30, yeah, okay.
So that's B, so this is 10/33 minus 44/33,
Yeah.
which is negative 34/33.
Yeah, that's right. I was thinking they were both thirds for some
Yeah.
reason.
And these would be amps.
Are we done then? Is that the problem?
That is one solution. I do want to do Kramer's rule.
So that was solving for the charges,
The current.
or the current 1, 2, and 3.
Yes.
Okay.
Yep. Kramer's rule, have you gotten to that in, who's done Kramer's rule before? You think you've done it?
Yeah.
I don't think I've gotten to it yet. But maybe, we might have done it in differential equations actually, or a little bit touched on it. I don't know
Okay.
why, but
Yeah. With the
it
heat
sounds
exchange.
familiar.
Okay. All right, Kramer's rule.
Kramer's rule is the one where you do you set up the box and then you like
Yeah,
do it that way?
yep, that's the one.
Yeah.
Determinants.
Oh, yeah, that's
Oh,
why we did
sorry.
it. We did determinants and differential equations, and
Okay.
that's where we did it.